So this is a bit of a challenge question. There's no doubt about that. Would I expect you to be able to do this sort of stuff on Friday? The answer is yes. So hopefully you can get yourself to that point. So let's just read the question. An object of mass 20 kilograms is at rest. A force of 30 newtons is applied to the object, but a friction force of 5 newtons exists on the surface. This force is applied for 4 seconds, and then the object coasts, only friction is present for another 4 seconds. Has the object now stopped? So you've got this box. It's at rest, so VI is 0. We are pushing on it with how much? 30. There is a friction force of -5, right? And it's going to move for, the whole thing's going to move for 4 seconds, right? And then what happens? Then it coasts. So then the 30 is removed, and it only has that force on it, 4 seconds. So there are 2 parts. So let's just see here. So at the start, I got F net equals F8 plus FF. 30 plus the -5 is 25. Is that correct?
Yep.
Absolutely. That's correct. Then what's the next step? Can you tell?
The acceleration part.
Yeah. F net equals ma. So I got 25. The mass is 20. Acceleration 1.25. Is that correct?
Yeah.
Yeah. So far so good. Then what's the next step? Over on the left there? Yeah, finding the final velocity. So A equals delta V over delta T. So 1.25 delta V for, oh, is that right?
No. No, it's 5.
It should be what?
5.
It should be 5. How'd you get 5?
Because
you got to multiply. And clearly 1 times 4, if it was just 1 times 4 is 4. 1.25 times 4 is going to be more than 4, is it not? So yeah, so what do you think that person did? I think they divided it. Yeah, so the delta V there should be 5, which means that the final velocity is 5. Now, is that all? I think, Ciara, I led you astray. Because the next part is the coasting part. What is the net force when it is coasting right here? It is only -5. So the next step should be F net equals ma. So this is going to be -5. Our acceleration, our mass is still 20. So what is our A?
-4.
-4? How'd you get that? Don't you divide both sides by 20? I think it's -0.25, is it not? Is it not?
Yeah.
Right?
Yeah.
And now what? Now we go to the next step here, which says A equals delta V over delta T. The acceleration is -0.25. Delta V for, this time they did it right. The delta V is -5 meters per second. Right? Actually, they didn't do it 100% right, did they? Because that should be negative. And then, oh, that's not 5. It should be what? -1. Thank you. -1. So now we're going to go delta V equals VF minus VI. So -1. What's the final velocity? We don't know. After the coasting, we don't know. We know that the initial velocity is this 5 right here. And when it goes to the other side, it becomes +5, right? So 5 minus 1, so what is the final velocity? 4. Has it stopped? No, it has not stopped. So they got that part right, but they didn't get the numbers right, did they? How many marks do you think that whole thing would be worth? 6? How much would this person have gotten?
2, great.
Did they do this step right here where they made that first initial mistake? Did they do the setup right?
Yeah.
They did the setup right, they just didn't do the solving part right. I would take a half off of that. And then what about the coasting part, that 25 in there?
That's at least a full mark.
I think that's a full mark. Why is that worth a full mark?
That's the
And it
concept.
says right there.
That's a concept. It's not a mistake, right? Yes. So likely 1.5 off. That would be 4.5 out of 6. Right?
Yeah.
Not bad, but you need to be able to do stuff like that.
Not too shabby.
Okay. So the pink sheet from like 2 days ago, the one that says hand in, the one that says due on a certain day, and if you don't get it done, you have to do the alternate one because I'm going to post the answers so that you got them for the test.
Which one is
This one right here, I am because I want people to know the answers. No. You have to hand this in today. I'm going to post the answers tonight. And if you don't hand it in today, then you're going to give another one, the alternate one. You got to start over again. So you either got to get it all done, or don't do it at all and wait for the alternate one.
okay.
Okay? I've got a couple of these in already. So I suggest you get going, and I also recommend that you get that lab done as well. Okay? So get going.
I think that's the ultimate one way harder. Pretty
The final. Push it for that same final velocity from that interval is no way to express.
It was like, behind. Because you're not your car to be car can be full of your
They're going there.
Yeah, it's like
Hold the car at rest. Hold the car at rest. Person is. Hold the car at rest. Struck her behind. Lay by the head of the victim. Seems to be thrown down.
where your body's
Oh, your body is different than the car. Yeah, okay, Nick. Every time. You're done. Hey, then you're done. Going back.
Are you able to help us at all?
I'll let you ask me questions. Sometimes doing that is worth it.
Like, where it says, why you push back on the house when it's when they first started.
Say again?
So, question for this.
Yeah?
And I kind of understand it. I don't want to apply the science.
Well, just explain it to me in words, and then maybe do a first draft orally.
Well, like, since the lights are right.
Yeah.
Real.
Okay. How about I'll give you a small hint. How about you draw a three-body diagram of it during the acceleration phase, and then draw a three-body diagram of it during the maintaining constant velocity phase. Maybe that'll help.
You're crazy. Okay, that might help.
If the acceleration of the body is zero, what does that mean? Like,
The acceleration, oh, the what is zero? The acceleration is zero. Are there any forces? Pushes or pulls. Explain thoroughly. Don't just give me a one-word answer. Junior, Leo.
What force do you like to like when it's not?
Say again?
I don't understand like
Well, when you're just getting the bike going, you're obviously pushing, right? Is there friction? Okay. When you're just pedaling at a constant speed, are you still pushing? Is there friction? When you're going at a constant speed?
Yeah.
Okay.
That's what I don't understand is friction.
Friction in both, right?
And
Okay.
there's force being applied for.
Are you pushing? Doesn't it ask why do you have to push more at the start?
Yeah.
Okay. So what is more at the start?
Friction.
No. The applied force is more at the start. The question
I
is
don't know why.
why?
That's what I don't know.
Well, that's what I'm trying to get you to answer.
I don't understand.
Okay. Well, unfortunately, I'm going to post it. I have given you enough information over the last week and a half that you should be able. If you want to look back at the notes, you can. I got you. It was. Okay, Junior, take it down a notch.